next one, acceleration. If you remember, again, roughly speaking, acceleration is v by t. Okay, roughly speaking, acceleration is v by t, that is velocity by time. So how to find dimensions? Velocity's dimensions, L raised to 1, t raised to minus 1. Clear or not clear? Velocity's dimensions, L raised to 1, t raised to minus 1, divided by times dimensions. T is time itself, right? So finally this becomes L raised to 1, t raised to minus 2. Did you understand this, everyone? Is this clear? Power is subtracted in division. Easy છે. 11th 12th physics બધું easy છે. બરાબર ને? ખાલી સાચી રીતે કરવાનું. So it's easy. Okay, don't try to mug anything up unnecessarily. Okay, so we got L raised to 1, t raised to minus 1, so minus 2. Next, force. Formula is F is equal to ma, isn't it? Simple formula. So its dimensions or dimensional formula will be mass. M is mass, m raised to 1 or just m. A, acceleration. What is formula for dimensional formula for acceleration? L raised to 1, t raised to minus 2. Is this understood? You can raise your hand as well. Okay, you can raise your hand as well. Right? Let's make a rule, everyone. Listen to this. Everyone. Let's make a rule. If you want to say yes, you just raise your hand. Okay? That will be easier. Got it? If you want to say yes, you raise your hand. If you have a doubt or something, if you have a question, if you have a comment, then you put it in the chat box. Alright? Okay? Again, raise your hand for yes, and for other things, comments, doubts, or some queries or anything, right? You can type it into the chat box. Okay? Four. Next, number 5. Number 5. Momentum. Okay, momentum formula is small p equal to mv. M is mass, v is speed. So that will give momentum. Dimension formula of. Give it a try yourself, everyone. Come on. I hope now we have learned the basics. Mass into velocity. Its dimensional formula. Come on, everyone. Mass into velocity. Its dimensional formula. No, there, not right. Be careful. Okay, many of you are getting it right, some of you are getting it wrong as well. Okay, here's the answer. See, mass capital M, isn't it? From the fundamental quantities, right? 7 fundamental quantities, mass, capital M is dimensional symbol. V, velocity. Okay, what's the dimensional formula for velocity? L raised to 1, t raised to minus 1. So this is your final answer. Did you understand? It's easy, isn't it? And it's based on powers. I hope you realize that this is based on powers and exponents. Yes or no? Do you agree with me that this whole thing is all about powers and exponents? So that's why I had to give you that basic assignment, right? Next, after momentum, let's go to pressure. Okay, no, first, just one. Area. Okay, any kind of area. See, surface area, curved surface area, total surface area, flat area, any kind of area. Alright, all areas use a very simple formula. Area's formula for anything or in general, square, L square. Alright? Is this clear? Area's formula, L square. I know it's not, we are not given that we are talking about a square, but listen, every kind of area is area, isn't it? You understand what I'm saying? Whether it's area of square, or it's area of circle, or it's surface area of a sphere, or it's surface area of a cylinder. Area is ultimately area. So its dimensional formula will always be the same, right? That is L raised to 2. Did you understand? Is this clear, everyone? L raised to 2. Clear or not clear for area? You might say, what if we find by some other way? Right? Let's do that one. Suppose you don't like A equal to L square. Suppose you don't want to use that formula. Let's say you use another formula. Let's see what happens. Let's see what happens. Suppose pi r squared. Okay, let's see. What happens now? First of all, let's look at pi. What's pi? Pi is a number, isn't it? Pi is a number. Do you agree with me? It's not a quantity. It is not a quantity. It is a number. Clear? Now, a number cannot have dimension. Why? Can you write a number in form of mass or length or time? Think about it. A number cannot be mass, length or time or anything related to that. Correct or not? You understood what I'm saying? A number cannot have dimensional formula like this. Okay, so basically we say, okay, you write it somewhere at the heading. It's an important sentence that you should remember. Okay, like I told you, at the start of every chapter you can leave 10 pages. That's where all these things can go. All right, clear? So what's the sentence? It is as follows: numbers have no dimensions. That is, they are dimensionless. We say that they are dimensionless. Numbers have no dimensions. We say that they are dimensionless. Mass also cannot have a number, right? Okay, mass is a quantity. So with mass you can associate a number, but mass itself is not a number. Alright, so you are almost true, almost correct. Okay. Yeah, so there is a question, what is meaning of dimensions here? What is meaning of dimensions? Again, if you recall, we have learned that a dimensional formula means we relate other quantities with the fundamental quantities, the 7 quantities. Alright? Okay? And when we say has no dimensions or is dimensionless, we are actually referring to these numbers. So for example, if someone will ask you, in momentum, what's the dimension of mass? I repeat, in momentum, what's the dimension of mass? Then the answer is 1. In momentum, what's the dimension of time? Then answer is -1. Did you understand? In momentum, what's the dimension of time? Then it's -1. Dia, what do you want to know the difference between? Do you want to know difference between force and momentum? Do you want to know the difference between force and momentum? Dia. I will not explain that right now. Again, I made it clear earlier. I am repeating. At this very moment, if I start explaining all these, then we'll have to cover 7 chapters together. Alright? It can only be done stepwise. You have learned basics of force, momentum in 9th standard. If you remember, very good. If you don't remember, no problem at all. Here you don't even need to know what is relation between momentum and force. I repeat, you don't need to know what is relation between momentum and force. There is a relation, I am telling you, there is a relation, but you don't need to know that, okay? Because for explaining what's the relation between force and momentum, I'll have to take you to chapter number 5. I'll have to take you to chapter number 5. Right now we are still doing chapter 2. Okay, so I hope you understand why I'm not giving answer to your question. Right? Again, I will not explain any of these things. Okay, what is pressure, what is momentum, what is force, what is area, blah blah blah. I will not explain any of that here. We will do it, but later. Right now, we are understanding using basic formula. How can we find dimensional formula? Okay, so for example, if you use pi r square, pi is a number, and numbers have no dimensions because you can't write number as a mass or a length or time or anything like that. So that's why wherever there are numbers, we simply ignore them in dimensional formula. We simply ignore them. See, even if you don't ignore, they are harmless. Even if you don't ignore, they are harmless. Did you understand what I have done here? Did you understand what I have done here? What's this for? What is this for? That is for pi. What is pi? Pi is a number, has no dimensions, means mass raised to 0, length raised to 0, time raised to 0. That is how you can represent a number pi, because it is dimensionless. Dimensionless, that is, does not have dimensions. Understood? Dimensionless, that is, does not have any dimension. No, nothing in mass, nothing in length, nothing in time, nothing in temperature, nothing in current, etc., etc. Because it's a number. A number cannot be in the form of all these. Clear? See, velocity. For example, velocity. Velocity is in the form of some displacement or distance by time. Correct or not? So here I can say velocity's dimensions are like this, because velocity depends on displacement and on time. Just like that thing, what does pi depend on? Does value of pi depend on mass? Think about it. Does it depend on length? Think about it. Does pi depend on mass or length or time or force? Does pi depend on these quantities? No. That's why pi has no relation with all the three. If I will write n raised to 1, it means I am saying pi depends on length. Okay, scary thing that the whole world of mathematics will change, right? If I say this is t raised to 1, then I say pi depends on time. Then I say pi depends on time, right? That's also ridiculous, don't you think? How can a value of a constant depend on time, right? So that's why 0, 0. Fine. So ultimately, what are the dimensions of area this way as well? Even this way, what are dimensions of area? Let's multiply everything. M raised to 0 means 1, n raised to 0 means 1, t raised to 0 means 1, and 1 into L square is how much? L square, isn't it? Clear or not clear? That however you do it, area's dimensions are always going to be L square. Always. You can find area of circle, you can find surface area of cylinder, no problem. Okay, let's go to next. Number 7, volume. Volume. Come on, this you have to do by yourself. Everybody, try it by yourself. Use a simple formula of volume and find out dimensions. Hurry up. Use a simple formula of volume and find out dimensions. So everywhere. Come on, I want more answers. Hurry up, people. Use a simple formula of volume. You only need to give your answer once. Everybody, okay, only give your answer once. Yeah, so L cube. Well done, people. Well done. Because we can use the cube formula. Volume of a cube is small L cube, isn't it? So L means length. Length, capital L raised to 3. Got it? So easy. Right? Next, number 8. Now, pressure. Come on. Do you remember basic formula of pressure? Basic formula of pressure. Basic formula of pressure. In 9th you would have learned it. Can you write it in the chat box? Pressure formula. Can you write it in the chat box? Only formula, not this one. This one later. This one later. What's the formula of pressure? What is the formula of pressure? Force divided by area. Force upon area. Very good. So, how to make this? Let's start. Force dimensions. See, this is the list of things that I expect you to remember. Okay? Force dimensions. M raised to 1, L raised to 1, T raised to minus 2. Clear or not? Numerator clear? Okay? Now denominator. Now time for denominator. Area. L square. So what will be the answer? Everyone in the chat box, come on, I want the answer from you. What will be the answer? What will be the answer? Match nu murder કરી નાખતા નહીં. Follow the power or exponent rules. Follow the power and exponent rules. Be careful with the mathematics, everyone. એટલે જ આ પ્રેક્ટિસ કરાવવી પડે છે. Don't make silly mistakes. Don't make silly mistakes. I'm seeing a lot of silly mistakes. I'm seeing so many silly mistakes here. Okay. Here is. Okay, everybody, put your hands down, please. Put your hands down now, everyone. And no more answers now. All right, no more answers. Time is up. No more answers. Put your hand down. Love. Dhruvraj, put your hand down. Dev. Very good. Okay. Over here. So mass, no change, m raised to 1. Now here, L raised to 1 upon L raised to 2. So when you divide, the powers are subtracted. I'm sure you learned that in your basic assignment. Okay, okay, that's the reason why we have to, that's the reason why we need to know all that. Okay, so m raised to 1, L raised to 1 minus 2, T raised to minus 2. So ultimately, what's the final answer? What's the final answer? This. Okay? Clear? Who got it right before me? Who got it right before me? Raise your hand. Who got it right before me? Raise your hand. Very good. Congratulations. Others, don't worry. Keep trying, right? I'm sure you just made a very minor mistake somewhere. Okay? So next time be a little careful and it would be fine. Okay, let's go to next one. Let's go to next one. Put your hands down. Let's go to next one. Density. Density. Symbol of density is rho. Okay? You might be writing D in 9th or 10th, but now we will write rho. R-H-O. That's how you spell it. Rho. Okay? So, what's the formula of density? Mass upon volume. Isn't it? Mass upon volume. Come on, find it by yourselves. Hurry up. Find the answer by yourselves. Hurry up. Find the answer by yourself. And type the answer in the chat box. There should be no volume in the formula, everyone. There should be no volume in the formula. Just basic quantities: mass, length, time, temperature, etc., etc. Okay. So final answer is m raised to 1 l raised to minus 3. Why l raised to minus 3? Here's the step. L cube is for volume. Okay, so final answer gives m raised to 1 l raised to minus 3. Alright, so that's density. Okay, let's go to the last one for today. Number 10. Work or energy. Now, I don't know which formula you might be remembering for work or for energy. We can use either one. Okay. Let's use U is equal to mgh. Do you know this formula, everyone? Do you know U is equal to mgh? No, you don't know U equal to mgh? That's a little bit strange. Okay, no problem. Those who don't know this formula, you can also do it by this formula. Okay, K equal to half mv squared. Alright? Okay, so let's do it by this because some of you said you don't know that. Right. Half. What is half? Is half a quantity or half is a number? Is half a quantity or a number? Is half a quantity or a number? It's a number. Very good. It does not have dimensions. Okay, so forget about that. Now m, mass. M raised to 1. Speed or velocity. But you see, it's squared. I hope you understood what I said. It is squared. So L raised to 1, E raised to minus 1. Okay? Now we simplify this. So what would this become? Can you tell me the final answer? Use the rules of power. Okay? Use the rules of power. No, it's wrong. No, it's wrong again. Many of you have given correct answers. Very good. I'm not pointing out everybody's name. Okay, fine. I'm writing it here. See, it's that when you square and you have powers here, squaring will give double the power. That is basically, it will be like this. This 1 into 2 will be multiplied and this minus 1 into 2 is also multiplied. Okay? So finally this becomes m raised to 1, L raised to 1 into 2 is 2 and E raised to minus 2. This is your final answer. Alright? So that's the thing for work or energy. See, you can check it. You can check it by this also, you will get the same answer. You can check it by this also, you will get the same answer. Alright? So these are the 10. These are the 10 that you have to remember. Okay? Tomorrow I am going to ask you. And whosoever I ask will have to give answer quickly. These are the 10 that you should remember. Alright? 10 dimensional formula. Okay? That's it for today. Goodbye everyone.